I'm good. You know, geez, I thought I turned this on. There's there. So as you're getting settled, I'd like to welcome you to this session. This is the award ceremony. It catches you up on the awards that you might have slept in this morning. It was just to say, as you offer my personal thanks, gratitude to Vicha for putting together a fantastic ICSE. I'll just say that I've only been to 20 ICSEs. I've planned 2 or 3 of them. And I know the logistics and the effort and the tens of thousands of emails that are exchanged. And as I said, if you grade ICSEs on a scale from 1 to 10, this is at least an 11 or a 12. He has really done a phenomenal job, and I wanted to extend my personal appreciation for what I know is a lot of hard work and also success in delegating, because the work is just not the responsibility of the general chair, it's for the hundreds of volunteers, students, faculty, et cetera, who are on the organizational committee who made this all possible. So, thank you very much. So in the brief time that I'm up here, as I said, I'm going to summarize the awards that took place previous to today. And then we will be announcing the awardees for the 2 particular distinctions that were only evaluated and decided this morning. So with that, I call your attention to the fact that page 44 in your program has all the distinguished papers in the research track. The near track had 2 winners today, one for combining spreadsheet smells for improving fault prediction, and the other for hierarchical learning of cross-language mappings through distributed vector representation. Last night at the town hall meeting, the IEEE Software Best Software Engineering Practice paper was awarded. And yes, you can see once again in review. And then the Software Engineering and Society paper was awarded this morning for the role of foundations in open source projects. And Software Engineering Education and Training distinguished paper went to Valerie Borsetti. And finally, the one award that was presented this morning that is not in your program was the Doctoral Consortium. And I'm pleased to say that Akram Rahman from North Carolina State University was the recipient of the Doctoral Symposium Award. With that said, there are 2 professional societies who are sponsors and are part of the steering committee that helps continue the tradition of ICSE. That has, if you were here yesterday, you saw the illustrious group of individuals who are dedicated, I would say, a large portion of their lives of making this ICSE conference a success. And I will, as for a advertisement for both the IEEE TCSE and SIGFOS, is that if you're not a member, please join. It's relatively inexpensive, and there are a lot of opportunities beyond just ICSE to network, to communicate, to contribute. So we are looking for volunteers. Yes, and contact me or Rick or Nino if you have any questions. So these are the awards in particular that TCSE has given last night, and SIGSOF had a similar complement of awards, of which we will hear one today. So with that, without further ado, I'd like to introduce Olga Baisal and Sun Jun. Ask them to come up on stage, and they will introduce the winners, announce, and give the awards. Yes.
All right. So, well, let me say that, well, the first lady there is, she's not available, not here today, so I'll be doing this. And then can I show you quickly the winners? So after 3 rounds of selection, these are the winners for this year's competition. Can I have all the recipients to be on stage for these shiny medals? Yep, so while I'm announcing the winners. So for the graduate category, we have the gold medal, Mohammed, on big data and debugging big data analytics, and silver medal for combining simple execution and model checking to verify MPI programs, bronze medal for Sheffield on automatically finding bugs in commercial CPS development tool chains. And then for gold medal on this undergraduate category, we have you're here. Asher on adding Sparkle to social coding. Just to like to add that Asher is a second-year undergraduate student, and then he published a full paper at the ICSE, so which is why he's making this.
So come over this way. Okay. Yeah. Moving on, we have a score of individuals being recognized for their achievements in the Student Software Engineering contest. I would ask them all to come up on stage now, and you will individually be recognized, and you're called to come stage right. So Christine Julian and Raphael Prikolatniki, would you also please come up and announce and give out the awards?
Oh, sorry. Thank you, Will, for the introduction. So as the students come onto stage, I want to give a little bit of overview of what SCORE is, because it's kind of a really special competition. So Ref and I were both very flattered to be asked to do this, because it's near and dear to several people's hearts, and so we hope we made everybody proud. It's a worldwide competition for undergraduate and master's level graduate students who work usually over a semester, sometimes longer than a semester, to put together real software engineering projects, not just programming projects, but kind of end-to-end projects. By the numbers, we had 29 teams register to compete. 19 of them actually completed projects to a degree where they were able to submit a summary report in January. We reviewed those summary reports and we selected 6 finalists. The finalists actually assemble an artifact, usually a virtual machine or a container, that is then sent back out to the panel of judges to actually evaluate all of the pieces of that large artifact. And from that, we selected 3 semifinalists. These are the semifinalist teams that you see here, and they're representative of the really hard and impressive work that all of the students put into the score competition. They're also representative of many other things that we're very proud of for the score competition. These students are from all over the world, which you will see in a second. These students also range from very junior undergraduate students to very senior master's level students. So we're very proud of all of the work that they did, and I want to give them all a round of applause for all of that very hard work. And Raphael will tell you who the winners are.
Okay, so before I announce the winner, I just want to make one acknowledge that as per the rule of the conference, we are allowed to bring 1 student per team to be here and present their work. So Ivica and all the organizing committee was so kind and so flexible, so we were able to bring actually almost all the members of all teams to be here with us today. So for the 3rd place, we have the team from Brazil. So the project is Travelendar by CPS Software. So you can come up here to get the certificates. Okay, so then the second is the team from Turkey. So please come up and get your certificate. And the first place is a distributed team from Italy and Croatia. So congratulations, come up to here to get your certificate.
And with that, I'm now going to turn the podium over to Matt Dwyer, who will introduce the ICSE N-10 most influential paper.
Represent my co-chair, Volker Groen. We were the PC co-chairs 10 years ago at ICSE 2008, and as most of you know, it's a tradition to look back 10 years and try to identify a paper that was particularly influential. And the way that we pursued it this year was to draw a very large net, find a lot of great papers. Then we engaged in about 2 weeks of detailed discussion about those papers. And after that, a group of previous award winners, Volker and myself, voted and selected a paper that we think was wonderful at the time, and in hindsight is even more interesting and impactful. And so it's my pleasure to announce the winner, and that's the paper Debugging Reinvented, Asking and Answering Why and Why Not Questions About Program Behavior. And we're lucky to have Andy Coe here representing himself and his co-author Brad Myers. So please. Thank you.
All right, get back. All right, quick machine change. Okay. I think we're good to go. First, thank you so much for coming to this final award session, staying awake the whole week. I'm sure you're all pretty exhausted. It's been an exciting and riveting and exhausting week for me, too. And thank you for the recognition, especially to Matt and Volker and the committee for looking at this work and recognizing it. It's quite the honor, so I really appreciate the recognition. I want to start off by trying to just recognize the broader community that just made the work possible first. And that'll be one of my first points, is just talking about community. So I'm going to start off by just giving some sincere thanks to people who really shaped some of the ideas behind the Y line. And the first person, an attendee here, is my undergraduate research mentor, Margaret Burnett. So she was just instrumental in me being here at all. She introduced me to HCI and software engineering. She taught me how to think, how to read, how to write, how to develop scientific arguments, and this was all when I was just a freshman as an undergraduate at Oregon State in computer science. I would not be a scientist if it weren't for her. I would not be standing here today if it weren't for her. So she really helped me navigate my way to graduate school, and she deserves a lot of recognition just for all of the mentorship that she's given me and all of the other students she's mentored in the past. All right, next thank you is Brad, my advisor and co-author for this work. 10 years ago when I started publishing this, and the several years before when we started thinking about these ideas, he was the one who seeded me with this really interesting and provocative vision of what if machines had to explain themselves? That was the question that he asked me, and it wasn't really much more than that, but it was a vision to try to chew into and think through and try to understand, and it was really just his relentless constructive critique and his really unbounded availability to just help me learn, that helped me move through that problem really quickly and give me guidance on it. He was an amazing mentor as well, so I just want to thank Brad for that too, even though he's not here. Let's go ahead and give him a round of applause too. Another thank you is you. This is my 13th ICSE. I've been part of this community for quite some time, and every single year, this community's taught me all kinds of fascinating things about technical rigor and really tested the limits of my humanism that's really driven a lot of the background that I have in HCI that I've brought to software engineering. And so I really want to thank this community for really giving all of these really powerful ideas from then 30-year history of dependencies and analysis and architecture and program comprehension and encapsulation and modularity. These are things that were not part of my training in HCI, but became really part of the foundational expertise that I had that allowed me to do that. So pat yourself on the back for really making valuable ideas that were there for me to build upon. And then finally, in getting to one of the bigger ideas, is thank you to academia in entirety. When I think back on sort of all of the time that I've spent doing research and this project and other projects, I've been really fortunate to have a lot of really amazing and outstanding teachers across my lifespan. And I think a really important point is that it hasn't just been teachers in computer science in my higher education, but teachers throughout K-12 in all kinds of subjects. So I'll just list some here because I think they're really interesting. Great teachers in physics, sociology, math, psychology, neuroscience, business, English, philosophy, design, art, learning, and even chemical engineering. I took a one-credit chemical engineering class on plastics and had professors and teachers in all of those contexts that were really formative in how I think about science, how I think about research, how I think about engineering. And a lot of my ideas, and I think many probably of your ideas, are just compositions of some of those ideas that we've learned from our teachers. So I think recognizing that this is really a broad community effort that we're all engaged in and not something that we're all doing in solitary is a key part of thinking about how we do scholarship. So I'm going to transition now to talking about big ideas, and because of all of the community that's really shaped my ideas and the ideas that we've built upon, I want to talk a lot less about the ideas in the Y-line and a lot more about where they came from. But to do that, I want to use the Y-line as an example, use the project as an example, and so I'll give a little bit of a primer on the Y-line and its impact just so we all have some common ground to build upon. So here's the brief primer. There's me 10 years ago in Leipzig, Germany, about 900 kilometers south of here. This was at ICSE presenting the work originally. And this was actually just one of 4 papers that I published on this idea across 7 years during my PhD and my first year as faculty at the University of Washington. And I'm going to try to just distill all of that work into just one slide to give you an essence of what the core insight was that made the work actually valuable. And so here's the key insight, and I'm going to frame it as a theory. So debugging is slow because developers iteratively test really brittle hypotheses about what caused the failure by manually collecting runtime data. And this little visualization you'll see on the right, it's sort of bouncing back and forth between possible explanations, right, as you gather data. So this is sort of an abstract description of what most of you probably experience when you're debugging, right? It's a lot of guessing and checking of your belief about what happened at runtime. Eventually we get there, and that's fine, but I argued in this work that this is slow because there's not a lot of guidance around what you're certain about and what you're not. So there's just a lot of guessing that drives that process, and that revision takes a lot of time. So the argument here was that debugging would be faster if developers worked backwards from some well-understood failure that they knew was a failure, and then rigorously and systematically worked from that known failure from cause to cause, verifying the underlying reasons for why that failure happened. And this is really just saying that a root cause analysis that works backwards with evidence is going to be faster than the scientific method, which involves generating hypotheses, testing them, refining them, and until you converge towards an answer. So that's what the essence of this idea really was, right? It was about strategy. It was about talking about what would make for a successful and effective debugging strategy. And so the way that I demonstrated that that was true was really by building a tool that sort of encapsulated that big idea. And the tool was, in essence, just capturing an execution trace of everything that happened at runtime and reconstructing a history of output, and then allowing a developer to interrogate that output and say, well, why was this line black? It should have been something else. Or why was this value 6? Or why didn't this happen? And by starting from that known failure, which is really strong evidence, and working backwards, you can get to the cause. And so then the way that we responded with those questions that developers selected in the interface is by giving them an answer, which was a precise backwards dynamic slice on that output property that they selected. Now, the really key thing here was that we did not give them the entire slice. If you don't know program slicing, the idea of a slice is to give the subset of things that happened at runtime, for at least a dynamic one, that ultimately contributed directly or indirectly to causing that value at runtime. But instead of giving all of those lines of code and all of those runtime events that happened, we just gave an interactive slice and let the developers step one step at a time through that causality, verifying the things that they observed, and using all of their knowledge of the architecture of the system and its requirements to try to understand what the source of the defect actually was. And that was a really key insight, that it was their knowledge that was actually making them search through that slice more efficiently and effectively than before. And I'll get back to this later when I make a point. So just to summarize some of the key results here, novices with the Y-line debugged 8 times faster than novices without it in one study. Novices with the Y-line were about twice as fast as experts without the Y-line. And experts with the Y-line are about 3 times more successful and twice as fast than experts without it. So these are pretty big effects, really coming from that core observation that root cause analysis is better than the scientific method when it comes to debugging. I won't dwell too much on impact. That's not why we're here. I want to make this a valuable talk for you, but there were lots of papers that cited it, lots of techniques that built upon it across lots of different fields of computer science, and it triggered a lot of resurgence in sort of looking at dynamic and time travel debugging techniques, and so I think those are really exciting and powerful things. There was also some industry impact and continues to be. It triggered Adobe to start thinking about debugging tools in this way, Microsoft to start building lots of time travel debugging tools in this way, and continues to now for other platforms like JavaScript. And then some of my students have gone off to other places to take some of these ideas as well. So Apple and Safari's developer tools are looking at this with my student Brian Berg, and Code.org has started adopting these in some of their educational technologies for teaching computer science. Now, all these ideas, all this evidence, all of this impact is great, but how much credit do I really deserve, right? If you look at some of these ideas, it's, again, just a composition of a lot of other ideas from other places. And in fact, a lot of the process that I used to arrive at them was following practices from really old ideas about how to do scholarship that are important to think about too. So I want to talk about some of those big ideas from science and just show how it is that Brad and I arrived at these ideas, and how it is that you might leverage some of those same old ideas from science to try to improve your work too. So here's big idea number one. Reading accelerates innovation. So Linus Pauling, who was also an Oregon State alum like myself, he was a Nobel laureate in chemistry. He said the way to get good ideas is to get lots of ideas and throw the bad ones away. And there were a lot of places where this was posted on campus, and I saw this a lot while I was walking around Oregon State. And so when I saw this as an undergraduate, one of the ways that I interpreted this was to never forget that there are really hundreds of thousands of research papers in the archive, all with really powerful ideas, and that we should use them. We should leverage them to inform our work, right? We should just read them. And so one of the things that I did when I was first starting in graduate school and beginning work on the Y-line was spent 3 months reading all of the papers I could find, not only about debugging, but about every other related topic, whether it was diagnostics, human error, root cause analysis, anything I could find beyond the boundaries of CS, and within the boundaries of CS that might be relevant. So when I was doing this work, it wasn't that I was so creative that I came up with this idea of thinking about diagnostics in a different way. It's that I was leveraging ideas that had been built off of 100 years of research from other disciplines, not just my own. Here's one of the papers that was really impactful. You might not know it existed, but Mark Weiser's original program slicing paper cited it as motivation for that original algorithm. And it was actually a paper published in a human factors journal by a psychologist who happened to be studying debugging. And it showed that debugging required analyzing data flow, that developers satisfied their data flow analysis. They didn't do it completely, they kind of did it partially, and that they analyzed many more irrelevant statements than relevant statements because they had no guiding theory about what the cause of something was while they were debugging. That was the basis of the work that I did. So it was this paper from 26 years before I had started this work that was really the inspiration for some of these ideas. It wasn't that I had just come up with this idea out of nothing. I really borrowed it from something that had been around for a few decades at that point. All right, big idea number two is that observation develops insight. And I think this is a subtle point, but Alexis Carrel, another Nobel laureate from physiology and medicine, he said that a few observations and much reasoning lead to error. Many observations and a little reasoning lead to truth. And the idea here was similar to the training I received in HCI, which was I took this to mean that if I didn't deeply understand the phenomena that I was trying to investigate, which was debugging, I couldn't simplify it. I couldn't fix it. I couldn't change it. No matter how much I reasoned about it analytically, if I didn't have an intuition for how debugging worked, I wouldn't be able to sort of understand what was going to work when I was inventing new technologies. And so before ever laying down any code or writing any prototypes, I spent another 3 months reading and observing people debug. Hundreds of novices and experts, and reflecting on my own debugging practices. And this led to this really rich intuition around how debugging works as an activity, not just one that's grounded in data and evidence and analysis, but one that was just grounded in observation, right? It gave me an intuition. And I still use this intuition today when I am doing my own research, when I'm reviewing papers about debugging. These are the kinds of intuitions that I use to judge, is work moving in the right direction? Is it going to solve a problem? So we really can't discount this intuition in shaping the more objective work that we do in science and engineering. All right, big idea number 3 from science, explain why, not just how. I'm going to go all the way back to Leonardo da Vinci, who said, "He who loves practice without theory is like the sailor who boards ship without a rudder and a compass and never knows where he may cast." So I took this to mean that the true value of inventions, including the technologies that we all make here, is that it's not so much in what they do and how they work, but why they work. Why would it be that any of the things that we invent actually are effective in practice? That's theory, right? That's an explanation for why something works. And it's these explanations that are actually the generalizable knowledge that stands the test of time, right? It's what allows that knowledge to transfer from tool to tool. My Java Y-line prototype that I published, right, and did experiments on, doesn't compile anymore. Nobody can actually use it, right? The thing that lasts is actually the explanation of why it worked. And that's the thing that transfers to whatever new version of that somebody might create in the future. And so the key thing that made the Y-line work was that intuition about debugging and a theory about what would make it effective. And it was that theory and not the tool itself that was the core of the innovation. So one way that I like to think of tools that we invent is actually as embodiments of those theories. They're a way of manifesting our beliefs about how people do their work and what's going to shape their work. And tools are something that can guide that and mediate that, but they're sort of secondary to that big idea underlying it. All right. All of that is to say that most of the ideas in the Y-line I borrowed from other places and assembled together, and that's how creativity works, that's how innovation works, that's how science works. And so none of these practices and none of these ideas were really my own in isolation. But when we do research and we compose them together and we find new things from that, there are new things that we discover. I didn't really know what was new about the Y-line when I did it. I felt like this is a nice tool, and it seemed new, and other people thought it seemed new. 10 years later, I understand a bit more about what is new about it and what's significant about it. So I'm going to share two ideas that have shaped my work over time, but have also been influenced by lots and lots of other research in software engineering, in HCI, and other fields. And I think these two big ideas are something that are relevant to most of the research that we do in this field, so hopefully these are valuable to you as you move forward. Okay, big idea number 4. Automation is insufficient. So Mark Weiser in the program slicing paper, this is what he said. He said, in practice, slicing is fairly fast, here's claim number 1, and can often eliminate large numbers of unnecessary statements from slices of programs. That's the only claim he ever made in that paper. He never said it was useful in practice. Right? He said, this is an algorithm. This is what it can produce. This is its output. He didn't say, this is going to make people a lot faster at debugging. He didn't make any of those claims. And in fact, if you look at the 4,500 papers that have cited this paper, only 3 of them actually evaluated whether or not slicing was useful. And all of them found that slices are always too large, they're always too hard to navigate, and they're almost always incomprehensible at scale, and people can't do anything with them. They're not actually valuable or useful. Right? So that simple algorithm, which is really powerful and led to a lot of research in our community, just wasn't sufficient to be useful. Right? That's a really important observation for us to make. And the field's key mistake in all of that work was just assuming that useful slices are trivial for developers to express. It turns out when I investigated this with the Y-line, people didn't know what thing to investigate, what variable to investigate. And so we had to have an interface in which somebody expressed things about output, which they did understand and could interrogate, but they couldn't choose which variable to do a slice on. That wasn't something they could do well. And then second, the size of a slice actually doesn't determine its comprehensibility. Right? That was the belief in those 4,500 papers, that we need to make these things smaller, because if they're not smaller, people won't understand them. But the Y-line showed that that wasn't true. Right? So we needed a sort of investigation of utility here to understand that expressing a slice is hard, and there needs to be an interface for it, and that navigating a slice is hard, and that doing it interactively is actually more effective. And this actually required an entire re-architecting of how I did slicing in the Y-line, because it just didn't make sense as a batch algorithm. It only made sense as an interactive one. And so when we look at this in other settings, a lot of other people in this field have shown that automation is insufficient too. On refactoring, on static analysis, on machine learning, in most of these cases, also in HCI, you can throw a batch algorithm at someone, they won't understand its output, and suddenly you have to reconsider how to redesign it. And that's where a lot of things are moving in other fields. It's thinking about what happens when you take something interactive and you put it in an interactive loop. And so this is probably also true for a lot of the things that we work on in formal verification, program synthesis, testing, bug patching. What does it mean when there's a developer in the loop? And this leads to my last idea, which is that human augmentation, in most cases, in all of the evidence we've seen so far, is often more powerful than pure automation. We like to believe that with enough data and the right algorithms, our tools can really outperform all of the developers we're trying to help, and that we will someday replace them. I hear this a lot from my friends, especially in AI. And the Y-line showed that this just overlooks the power of developers' knowledge, of the things that they know about source, and the things that they even know about source they've never seen. So in the evaluations of the Y-line and the studies I mentioned, participants interacted with slices that would have been about 50,000 lines of code or larger, which should have been incomprehensible, right? But they actually only looked at about 30 lines of code when they were actually doing this. It just didn't matter how large they were, because they knew a lot more about how the system was architected and only had to look at 20 or 30 parts of that causal chain to identify where the defect was. So we ignore all of the knowledge developers have at our peril, and by leveraging the knowledge that they have, we can actually create systems that are much more powerful than we might expect by combining the expertise that a developer has with the ability for systems and tools to be systematic and thorough. And so there's a couple of consequences here if we ignore what developers know. Our innovations either aren't useful because they don't account for what developers know and they sort of collide with what developers know, or we just miss an opportunity to combine human and machine insights for even greater power. And so that's sort of a challenge to you, is to think about how to invent your tools for software engineering that focus on the entire system of your tool plus a developer, or your tool plus a developer plus a team, or your tool plus a developer plus a team plus an organization. And if you do that, not only will your tool have more impact, but it'll actually be more powerful than just the tool alone or just the developer alone. So that's the wisdom, and I'll just restate these just so you have them in your head. Read everything in and outside of CS and build upon it. That's so critical. We just don't do that enough in this field. We just don't read enough. 2, reasoning about a problem is insufficient. Go get a really personal, rich instinct about the problem that you're trying to solve by observing it. 3, try to explain why your tools work, not just how they work. Figure out why it would be that they would be so powerful. 4, don't assume that automation is enough. Developers know a lot more than you think, and they probably can do better than your tool. Figure out how your tool can make them smarter. And then 5, try to invent ways that combine all of that developer knowledge with machine insight. I think there's real research discoveries to make in that class of architectures that we don't investigate often enough. Thanks for your time and attention, and I'd be happy to take a few questions.
If you have questions, you can either come to the mic here or a mic back there. We have a couple minutes for questions. I'm sure Margaret has a question. She does?
Got a question up here.
I'm sorry, I can't. There.
Waving hand.
So I heard through the grapevine that there was a version of Y-line for Microsoft Word. Is that right?
Yes, there was a paper that Brad and I did with an undergraduate where we applied similar ideas to just a word processing interface. And the interesting thing there was that since the user of that word processor was not looking at the source code of the word processor, they were just dealing with its input and its output, we were trying to find out if similar ideas would work in that space too. And the interesting thing there was, what's an answer if not the internal causality of the software that's causing a word processor to do something? So here's an example. Your autocorrects a word, and you don't know why it did that, and you don't want it to do it anymore. So the idea was you just point on that word and say, why'd you do that? And then the answer that it gives is all in terms of the underlying user-visible inputs that caused that to happen. And in a word processor, that's often the checkbox that had that mode set on, right? And so you immediately go to that checkbox, and that's your answer, and then you can turn it off. So a really similar idea, kind of a different manifestation from an interface perspective, but the same sort of underlying algorithm. We just built it architecturally using an undo stack instead of precise backwards dynamic slicing.
I'm over here.
Oh, okay, right there.
Hey, hi Andy, what do you think is the role of tools in this community? It seems like there's a variety of different work. Y-line is an example of a fantastic tool. Lots of people are building tools. Conceptually, what do you think is a kind of a tool? What's the role of a tool in a research paper?
Yeah, that's a great question. So I spent some time in industry and have a good sense of what tools mean in industry. And in industry, tools are really powerful things that shape your process and your work and accelerate what you're doing, give you information and knowledge. And we like to think of them that way in research too. But in research, I tend to think of them as something a little bit different, right? Because the output of our work in research is a PDF, right? It's not an implementation. Maybe it's also an implementation that we share with the world, but in that case, what we're really doing is producing tools. So I think we also have to think when we write that PDF, what is the robust, lasting knowledge in that PDF that's powerful? And it's not a tool, right? It's an underlying idea about what shapes work to make it more productive, what makes a developer think more effectively. And those are those theories of our tools that we don't often make explicit. So James Sorbotopo and I were talking about what would it mean if all of us tried to really explicitly state in every paper we write when we contribute a tool why we think it's going to be effective in just one paragraph. Right now, when we read most papers, it's sort of 2 or 3 words or maybe a sentence, and it's sort of implicit. Let's make it explicit and interrogate whether or not those reasons are reasonable.
As a second question, if knowing everything that you know now, if you could go back and change something about that work that you've done, what would that be?
Part of it is actually sort of the impact of it from a tech transfer perspective. So it turns out that when you re-implement the entire runtime stack in order to create a debugging tool, getting that to transfer into product is really, really hard because you've changed so much about the way things work. And so I think there are versions of that prototype that would have been a little more reduced and a little more sort of the essence of the idea that would have been easier to put into the world and get into products. So a lot of the impact that I mentioned, it was getting little pieces of that architecture out into the world, but not the entire thing. So when you think about your ideas, try to think about how to reduce them to their essence so that you can find a way to get them into the world more easily, because every extra line of code in that prototype is probably an extra 6 months of implementation effort when you're talking about a real product.
Okay, I'd just like to thank Andy for both the Y-line work and the reflection on the Y-line work. And I think my students probably are not going to thank him because I'm going to suggest they go read 900 papers. So let's thank Andy.
Okay, good afternoon, everybody. So Marsha and I have great pleasure in announcing the final talk in this session by Andreas Seller, who is a co-founder of the Center for IT, Security, Privacy and Accountability in Germany. This award is the ACM SIGSOFT Outstanding Research Award for Andreas's foundational research on automated debugging and mining software repositories. This is an award that's given by ACM SIGSOFT annually to a researcher whose research has had profound, significant and lasting impact on the theory and practice of software engineering. And in the talk, you're going to hear about Andreas's excellent work on those 2 topics I mentioned, automated debugging and mining software repositories. But I just want to draw attention to 3 other aspects of his work which are less commonly recognized in our community. The first is that Andreas actually in his blog gives incredibly valuable, sage advice to all of us in the community, which we can all learn, both senior and junior researchers. So for example, if you look at his advice on how to write responses in the rebuttal period, I would recommend this. It's very useful advice. The second thing is that he introduces much needed levity into our community. We can take ourselves very seriously sometimes. And to pick out one example, I'd love for you to look at his post, his video post, very professionally done, I must say, on the 1st of April this year, where he introduced a fantastic new technology for helping reviewers do their job of reviewing. And finally, he actually teaches all of us how to give an excellent talk. And so I'm going to shut up now and let him show you just how good that is. You'll all be rewarded. If you haven't heard him speak before, I'm sure you're in for a real treat. So without any further ado, here's Andreas.
Okay, I'm going to set up things here just as well and see you can all hear me around. Okay. At some point, we should have a workshop on the topic. Glass of water. Great. Great, great, great. Oh. Okay. Thank you very much, everyone. This has been such a great conference, and I'd very much like to, again, thank all the organizers for delivering us such a wonderful and perfectly organized ICSE. And I know that this being the last talk, you're eager to get back to your planes and trains, to get back to your offices, to get back to friends and family, or in the other order. So in the next couple of minutes, I'm going to restrict myself to 3 short stories, not more, not less. All 3 of them are actually connected to some conference talk, so I guess I'm in the right place to relate to them. And here's my first one, which is almost 25 years ago. This is in 1993 at the German National Conference for Software Engineering in Dortmund, Germany. Is anyone from Dortmund here? Okay, then I can continue, that's good. In 1993, I am a PhD student, and this is my first talk ever. I am presenting an experimental programming environment named NORA. NORA stands for no real acronym, so it's pretty generic. But what this is about is actually one of the first uses of theory improvers in software engineering. My own topic at the time is using configuration management with feature logic, using features from feature logic to represent variability and changes and feature unification to show what happens when you put two components together. But my real key example on the day in Dortmund would be component search. We had an entire session on component search here at ICSE. But I'm not sure whether you've ever seen that. The idea is you'd have a huge library of components, which was all the rage at the time, and you'd be able to find a sorting function by specifying the pre- and post-conditions of the functions you'd be searching for. So you specify a pre- and a post-condition, and if there's any component which has a weaker precondition or a stronger post-condition, then it would be happily retrieved. So let's assume you're indeed searching for a sorting function, and therefore the post-condition is that the resulting array A prime is sorted. So this is the post-condition for a sorting function. Unfortunately, this post-condition is not enough because, well, any empty array that's returned fulfills that, or any sorted array for that matter. So you also have to specify that the output array is a permutation of the input array, which is approximately that. So after entering on this in our system, I was showing how our system would be now happily be able to retrieve the sorting function to determine that this was actually all correct. And at this moment, in the audience, there's an older professor who stands up and who shouts into the room, "When I search for a sorting function, I do grep sort." To the great laughter of all attendees, maybe 100, 150 people. And this was actually Manfred Nagel from Aachen University. And yeah, well, here I am, and I look to my advisor. He's sitting in the first row, crossing his arms and grinning. How would I get out of that? So I explained that this, of course, would not work for sorting alone, that you wouldn't even have to know the concept of sorting. You wouldn't even have to know the name of sorts, and this would still work. So I reconstruct this whole thing and try to explain this one more time when, unfortunately, this all breaks apart because there's a second guy coming. So I'm reconstructing this whole guy, and then it all breaks apart because there's a second guy coming in who again shouts into the audience. That's Jochen Ludewig from Stuttgart. You know, to me, this looks like a solution looking for a problem. I don't know how many ICSE talks you've ever seen where people come up in the middle of the talk and just shout into that. To me, this has happened twice, and this was my first talk as a PhD student. Okay, so this closes it. Essentially, I'm done. I go through the remaining slides, and I have more to show, but nobody listens anymore. And for the rest of the day, well, when there's people laughing and pointing when they see me, and essentially, I'm done. At the end of the day, I'm eager to take the train home, and I'm still enraged all the way back. Actually, I couldn't have had a worse introduction to the world of academic talks. So that was the story of my first talk. Story over yet? Not quite. There's a couple of ways I can spin the remainder of this story. So, for instance, I could tell how after being utterly devastated, I finally managed to find my path and still make a great career in computer science. Guys, girls, don't listen to what old white farts say. Follow your dreams, and in the end, you'll get married and have, you'll get tenured and have plenty of papers, and you'll stand on the stage and yeah, great ending. Here we go. Another way to spin this is from another angle. I could also say how important and ubiquitous theory improvers are today, how all of verification, testing, analysis depends on constraint solvers, model checkers, you name it. We were among the first to actually use these techniques, to actually show that they worked, and today we are right. Yeah, that's another way to spin this. But the spin I would love to give to the story is yet another one, namely the question of relevance. Because today, when I think back of this story, turns out that these guys shouting it into my talk were right all along. I mean, think of how programmers work when they search for some function today. I mean, they go to Google, they go to Stack Overflow. So much of programming is searching today. It's grep sort everywhere. So the essence of the story is that these two old farts were right all along. Developers actually want simple tools that work, not some made-up formalism that only PhD students come up with. One important consequence for me was that I started a sideline along my formal work on feature logic. And together with a student of mine, Dorothea Lütgehaus, already in my master's thesis, I had built a library that would go and visualize data structures. And we thought of integrating this into a debugger, and this then became DDD for a data display debugger. Here's a screenshot of DDD at the time. This is a pretty neat tool, so it has a full-fledged user interface. It has little stop signs for breakpoints and all. And at the top, you can see DDD nicely visualizing a linked list, and you can interactively explore the whole thing, not showing you the entire list at once, but clicking through it, exploring things. All this was pretty neat, and turned out that DDD was actually among the very first debuggers with a decent graphical user interface. Actually, technically speaking, it was almost all a user interface built on top of DBX and GDB and other command line debuggers. And people loved it, and it even became a GNU program. I got a nice letter by Richard Stallman. I hereby adopt DDD to be a GNU program. And developers from all over the world sent us postcards to thank us for making it available. I had a nice little shoebox in my office with plenty of postcards, some hand-drawn comics and everything. That was really neat. This was the feedback I got from the developers' world. Now compare that to the feedback I got from the academics world. So the postcards at this time were far more important to me than the citations I would get, because people were actually using my stuff and found what I was doing helpful for them. So this was because DDD was a tool that would get things done with an immediate usefulness for developers, concrete benefit, not just some abstract concept that may or may not be adopted. And the key metric here is usefulness. DDD was clearly useful, and this usefulness was that made it better than the state of practice. Usefulness, for me, this is the key metric in software engineering. So this experience prompted me to ask questions like, is my research actually useful, and for whom? What is it that developers, our customers, our key audience actually need? So here I was with my research. I was up there in the light, which was nice, feature logic, theory improvers, but still I felt out of place, and I wanted to know what was out there in the dark. So what is it that developers actually need? Well, we can ask them. There's a nice paper by a nice paper by Andy Bagel and Tom Zimmerman, 145 questions for data scientists and software engineering. Do people ever, for instance, do people ever write loop invariants? Does it help? How do we measure the productivity of our engineers? How do users typically use my application? And 142 questions more. It's a tremendously rich source for problems that we as a community can set out to solve. As a side note, I would like to point out the word recommender does not occur anywhere in that paper. Neither does the word model in the sense of software engineering occur anywhere, or the word repair also is apparently not yet in the scope of questions that developers ask or want from us. Remember this slide when I had my doubts? I think that we have a huge number of problems today, our problems that we are still facing after all these years, and we are very much still in this upper corner where the light is bright and where we know our strengths, but yet maybe we can venture a bit more out into the darkness. But when we are talking to developers, that's also something I had to learn. Do not assume that people will change just because of you. They will not adopt your method just because you say so. You may have to make sure that people can adopt your approach with minimal effort and pave a way towards this transition. And here I'm not ever sure whether our paper-centric culture, Andy put it, for producing a PDF, is the best way to achieve this. You're literally asking the reader to rebuild everything that you describe. And yet I think that tools are a much better way to achieve impact and relevance. But then this doesn't even have to be a conflict. We should go and bring both together, and I'd like to show a nice example for that, how this can look like. You may have heard of Jupyter notebooks, and if you haven't, you should have. They just got the Software System Award from ACM, so this is at the same scale as LLVM compilers or GCC or like things. And Jupyter is a tool that allows you to edit documents that consist both of text and code. It's like literate programming, but much more interactive. And the nice part about that is you can edit text elements, you can use Markdown syntax for that, yeah, but you can also work on the individual code parts. And whatever you enter as code, this is Python code, is immediately evaluated, and the result becomes part of your document. You can have arbitrary math in there. Here, this is one of the examples from my fuzzing lecture, where you can, once you have such a document, anyone can toy with it. You can invoke functions with variable arguments. You can edit the code just as you like. And you can, this is one of the larger fuzzing experiments in here. And you can also go and even integrate data visualizations at the very end. This is very much used in natural sciences in order to visualize data effects. This is a way to integrate algorithms, data, and the explanation text into one single document that everybody can deal with. You could have small programs that embody the gist of your algorithm, small programs that can be examined, can be experimented with, can be assessed, and that can be taught, can be used by others, used and reused again. So you'd have both the tool and the paper in one single document. You can even import documents each other. You're not even the site, you can import. You just get all the code, there you go. Why still have paper? That was my first story on relevance. Second story is on simplicity. 6 years later, it's 1999, and we are at ICSE FSC in Toulouse, France. At this point, I've completed my PhD on version control, and the experience with DDD had raised my interest in debugging. And I had come up with an idea that brings both together version control and debugging. And core of Delta debugging is very simple. You have a big set of influences. Here's a big set of things. And in here, there's a small set that causes what you're looking for. You can test whether what you're searching for is in that set. So you try out one half, it's not in there, you try the other half, so you keep that half. You repeat the process, remove one half, and turns out the effect is in there. Still split this into two halves. Now we are in the second half. It's not in the first half, but it's in the second half, so we can continue this narrowing down again and again. Now this is a bit small, so we go into large things. And you can still continue this whole process again and again. And this is what delta debugging gets you, the small subset that causes a bug. This can be in your input. This can be in your version history. This can be in your configuration. And it's typically a very tiny element or difference in a big, big set. So the actual implementation of delta debugging is very, very small. I never much bothered to write a tool about it that would be distributed because it would be very easy to implement it. All you'd have to take is, say, these 20 lines of Python and integrate them into whatever setting you're having, and then it would happily produce say, given a big input of 2,000 lines of nroff input, it would produce you the two characters that would reproduce a bug. So this is what I presented in Toulouse in '99, and it was well received, big applause and all. But after the talk, right, as I get out of the room, there's a senior professor from France, I think it was Jacques Estublier, who is very agitated. And he shouts at me, Andreas, I would never have thought that something so simple could be accepted at a scientific conference. Yeah. Again, here we were. How could I continue this story? Well, I could tell you something, how scientific styles differ from country to country. This wasn't meant to be laughable. If I wanted to impress my audience with my intellectual power, filling the talk with formulas and special terms such that nobody can follow and everybody recognizes my intellectual superiority, well, delta debugging was clearly not the thing to do that. I could also talk about how this raised doubts in me and whether I'd done the right thing. I mean, anybody could have come up with this. How did I deserve to be called a scientist? And how does the audience not see that I'm a fraud? However, the way I'd like to spin this story here is the simplicity. I mean, something so simple. What's the alternative to simplicity? Well, complexity. And complexity is our enemy. It is actually our job to control complexity. This is, as put forward in this wonderful quote by Pamela Zay, the purpose of software engineering is to control complexity, not create it. So let this be the essence of software engineering. And by the way, this is also what delta debugging is set to make complex things simpler. And I'd like to point out that it had taken me 1 year to make delta debugging as simple as it was. So making things simple is actually hard work. But simplicity makes all of our lives much better. And again, I'd like to hand out my kudos to Andy and Brad, whose approach to debugging is, for me, the epitome of simplicity. This is really, really simple. You navigate through the data flow, and it's so easy and so wonderfully done. I love it. But then, such simplicity is hard to find. A few years ago, I visited a high-profile graduate school, one of the best universities in the country, extremely selective, extremely ambitious. So there's 20, 25 students in the room, and they tell me that they are expected to produce 1 paper per year, to publish 1 paper per year, but not anywhere, actually at a flagship conference, ICSE, FSC, ASE. 1 year, 1 paper per year. Oh, it's just spent 1 year refining delta debugging. I don't think I had any paper published in '97 or '98. But then the good news is, it turns out that getting a paper accepted is actually easy. All you need is a recipe for doing research that will get accepted. One such recipe is you take a simple approach. You take a simple approach, say something we use every day, a napkin, for instance. Okay, but napkins, well, you add some increment to it. You make it more automated. You say you add machine learning to it. Make it dependent on context such that it will work only well in that context. If it doesn't work in that context, you cut it off. You integrate all of this into the user's environment. You just add and add stuff to it until it gets better. Say 2% more precision, 5% more area under the curve. Errors found that the original tool would not have found. And the great news is, reviewers so get this. Even if reviewers do not understand how your approach works at all, they will still understand the improvement. There's your paper. Great. What you then have is a complex approach that is better, but then, is this really the case? With such complexity, who wants to re-implement your approach? Who wants to use it? And remember, maybe it's time to apply such principles, our own principles, to our own research. There's more such recipes, of course, and you may argue, so what? Who cares about a paper too complex getting in? Well, the problem is that such papers actually obstruct the scientific progress, because the only way to get even better results is to build something that is even more complex. And this helps nobody. We end up with contraptions that are more and more complex, and yes, they automate something, and yes, they're better than manual work, yet it doesn't help. And sometimes I wonder, would something so simple as delta debugging get accepted today? Okay, we're short on time, so let me close with a third story. Again, 5 years later, it's a Saturday morning in 2004, and it's the day of the ICSE deadline. You obviously know ICSE deadlines. So at this point, I'm a tenured professor already. I'm actually a full professor, which is nice, and I got these positions through delta debugging and DDD, which were very well received. New thing, I now have students. Here's one. You know that guy? This is Tom Zimmerman. Tom, you're in the room somewhere? I haven't seen you yet. Okay, good. Here we are. And with Tom, we systematically analyze version histories for code changes. Code change means that you have a change that involves multiple components at once. And we find relationships in the version histories of open source software. For instance, whenever someone changes file.c, the file schema.jpg is also changed. Why is that? It turns out file.c has an embedded SQL statement, and schema.jpg in the documentation is a picture of the database schema. Whenever the database schema changes, or whenever the SQL statement changes, then the documentation is updated just as well. And this is how these two are related to each other. This is impossible to find with any kind of traditional program analysis. You'd have to put together C-file analysis, SQL code analysis, and actually image recognition for the schema.jpg, converting a pixel schema into a, well, you don't even want to think about it. But this is the kind of new relationships that we find, so we can go and recommend changes. This is all new. So whenever you change A, you also need to change B. And if you make a touch to file.c, this simply means that you also have to go to, that you can recommend that you should also go and look at the other file over there. Since this is all new to us, we struggle with accuracy metrics, which we have to learn first, such as precision and recall. All this is new to us, and it's also for the software engineering community. And for the next 2 years, I will always have a brief reminder of not to confuse precision and recall. Now I can do that. It's the Saturday of the deadline. Deadline for ICSE and other conferences always around noon in Europe, very convenient. And we are still struggling with these metrics because we are not entirely happy with precision and recall yet. This is when Tom calls in at 10 a.m., 2 hours before the deadline, and he says that he has found a way to boost precision and recall above 90%. And I tell him, this sounds great, but this sounds too good to be true. So I tell him to please check and recheck. And after a few minutes, well, after 1 hour actually, he calls me up again, and it turns out that he has accidentally trained from the testing set. So, yep. You know what this means, folks. Great to have so many great empirical software engineers around here. So we go back to our initial values and we submit. The reviewers are very mixed, actually, at the time. The reviewers clearly don't know what to do with this, but they accept anyway. And the title of the paper is Mining Version Histories to Guide Software Changes, and today it's one of the most cited papers, well, certainly of this conference, more than 1,200 citations. And 3 years ago, we got the Most Influential Paper Award. That's Tom, Stefan, Peter, and myself. And, well, this is how this paper came to be. Again, how could I spin this story? I could tell you something about how important it is to do thorough quality assurance, how to ensure that your results are reproducible, and yes, this is very, very important. I could also spin how lucky we were. In particular, Gail Murphy at the time and her student Annie Ying were working on exactly the same topic with exactly the same results. But they decided not to go for ICSE because they were unhappy with their results. So we went and we got in and we got cited, and well, they made a very nice journal paper out of it. That was very nice too, and we still are very much friends with each other, all of us. But still, it was our luck to actually get this in before others. But the lesson to be learned from this, for me, is innovation. Because the concerns we had about our numbers, about precision and recall, didn't matter. Because there was nothing to compare against. The approach was entirely new. We would find things that no one else would. And new was better. And for me, this was important because going from debugging to mining software archives was one step towards something new, and I've kept on moving since then, exploring dozens of new fields, sometimes successful, sometimes not so, but always learning, always innovating. And that's not me. That's me and many great students whom I admire and love very much, and work that would be simple and have impact in practice. We have seen delta debugging that narrows down failure causes. I have no recount how frequently it's being used, but there's standard tools that do it for you these days. Mining software archives yields empirical findings. We have an entire conference in that field. Also, more recently, grammar-based fuzzing, coming from our chair, which is a technique which we have initially developed for JavaScript interpreter testing. This is now being used on a daily basis on all browsers and has found so far more than 2,600 bugs in JavaScript interpreters, in Firefox, in Chrome, in Edge, you name it. When somebody comes along and asks me, so what are you doing for a living? And I ask them, are you using an internet browser? And they say yes. Well, the reason this internet browser works is partially because of our work, and I'm very happy to have that. Or even most recently, work on large-scale app store mining, where we go and compare the app behavior against their descriptions, which again prompted us to learn a lot about natural language processing and topic clustering and all that fell with it. Lots of fun learning all this. And again, these are techniques which are now in daily use at Google, at Microsoft. But for these, we'd also need patience. You see, you enter a new area, it takes a year at least to understand how it works, and if you have something really new, it can take many years until it gets cited. And I was very glad I had an environment that would trust me. This is the Saarland Informatics campus in Saarbrücken in Germany. When I got hired, I was the one candidate for this professor position with the lowest number of publications. They actually had read my papers and they loved them, so this is how I got hired. But nobody ever checked my publication counts. When I got hired, the only thing that matters, they told me, will be your impact. Even if it takes years or decades to build. And they took enormous risks. They put in an enormous trust. And they trusted me all this time. And here I am today. Thank you so much. At this moment, as I am standing here, I realize how lucky I was again and again. Most of us are unsung heroes who have to struggle hard in our daily work, trying to fulfill the most absurd incentives and regulations. And I missed so much of this. I was lucky, and my luck is why I am standing here. But still, whether you're lucky or not, these hold for all of us. If you're in the light, go out and explore the dark. Find out what's relevant. Find out simple solutions. Keep on innovating. Keep on innovating. Here we go. As the Romans say, sapere aude. Dare to think for yourself. Dare to be wise. Or simply, dare to know. That's it, folks. 3 stories, 3 takeaways on relevance, simplicity, and innovation. Now go out and create masterpieces of software engineering, and see you next year in Montreal. Thank you very much for your attention.
So we have some time for questions, and we have microphones here. So do please come up. Don't be shy. Come up and give some questions to Andreas on any of the topics he's talked about. I think you've left everyone stunned, Andreas. Yeah. So I think Per has a question.
Thank you very much, Andreas, and especially for your encouragement for all of us to do what we believe in. Can you share a little bit of your experience of sharing with students and colleagues when this standing on your own actually leads them to fail, or leads us to fail? How can we share that the situation when we did something we thought about and it was rejected, properly or not properly? How could we as colleagues, seniors, advisors, do that to still keep us up with what we believe in?
Yes, thank you very much for this question. This is a very tough question because it's difficult. It's not always easy to live up to your belief in environments that are frankly adversarial to that. As I said, I have been extremely lucky to be in an environment where we, that is in particular my older colleagues and myself, where we have worked over the years a lot to obtain a large degree of autonomy. That was great. And where we also have been lucky to have had successes that would allow us against, say, the university or our state to keep that autonomy, because we declared that this autonomy is necessary for us to have more successes. And at this point, I'm one of these successes. So this is another cornerstone for a great amount of autonomy. But I perfectly understand that there's plenty of environments where we are very much encouraged. You have to publish these many papers. You have to come up with this much money. But all of these are secondary effects to me. Yeah, and this is something that we have to communicate again and again. A publication count by itself is not a measure of success. Money that you bring in is not a measure of success. All papers, all the money that you get, all these are means to all these are means to achieve impact, and all these are means to achieve impact, and such impact is also not something that you can count year to year, but is something that you have to build for a long time. And I would be very, very happy, in particular for those of us who are in the more managerial positions, to fight for not short-term metrics of success, but to go for long-term metrics, possibly very high bars that you want to achieve, but simply say, in 10 years we want to be here. What is it that we can do? And in many cases, this will actually involve giving researchers the trust that they will actually be able to do all this.
Okay, thank you.
Congratulations for such a well-deserved honor and award. I have two somewhat related questions. I think earlier you mentioned on the local administration, how they could provide incentive for such impactful research. Do you have any suggestion for like a conference organization such as ICSE or like professional organizations, ICSOF, TCSE, how we are as a community, we could provide better incentive for such impactful research, especially for younger researchers like students or junior professors? The second question is on like how we can, as a community, promote the reputation and the impact or visibility of our software engineering field outside of our field, for example, in the general computing society, right? I mean, in order to attract more resources and investment and attention to our field. Thank you.
I wish I had answers. I wish I had great and crisp answers to all of these questions. But again, for me, the thing is, there was a nice study from Nature or Science about a year ago, where they showed that those papers that ultimately get cited the most actually are not at all cited in the first couple of years that they get published. Meaning that at each and every conference, you will have a number of papers that are barely accepted because people don't really know what to do with them, and whose true value will only uncover a couple of years later, because then you will realize that those folks submitting actually were ahead of their time. And sometimes I also worry that that there would be many such papers who even don't get into the conference. And we have learned a lot as a community in the past decade to focus on evaluations and focus on really pointing out how much better our tools and our approaches are than the state of the art. But I think that we should also look back and see and actually do a bit more qualitative evaluation on how revolutionary could this possibly be? How does this bring our field truly forward? And what is it that could come out of that? And this is mainly a call for the reviewers among us, or for those of us who will be reviewers soon. And this is also something how we can give our community a push forward sometimes towards a bit more crazy ideas than what we have right now.
Hi, great talk. Over here, up this way.
There we go. Okay, great. Okay, see you.
Your simplicity story really resonated with me. Is there anything you think specific that we can change in our review processes or conferences to encourage people to write and speak more simply?
Simplicity, I think, is something that all of us sometimes long for. I think every human would like to have things more simple, be it in politics, be it in human relationships, be it in research. This is something we all would love to have things that are more easily explainable. And this is, of course, a wish from me just as well. But and I think that, but then again, I think that we as researchers should indeed also strive for simplicity. We should go and evaluate the most simplest approaches that we can possibly find. And because if it turns out that progress can only be made by avoiding simplicity, by bringing up more complexity, then this progress is actually very, very questionable. And if you come up, this is what we're doing right now in my testing course. I'm holding a course on generating software tests. If all works well, there's going to be a book out of that right now. And I'm actually re-implementing many of the core ideas of test case generation, search-based software engineering, symbolic testing, and all, in very simple Python programs. And it turns out that the core ideas actually all fit into 200 lines of code. In particular, when you can say, import AST, you have an interface for an abstract syntax tree, you write import Z3, you have a constraint solver at your disposition, and boom, you can very easily solve the constraints that lead to a particular path in the program. And this experience has prompted me to promote this concept. Take the gist of your algorithm, implement it in a very simple to use fashion, in a fashion that is very simple to teach. And of course, a true industrial implementation will need more bells and whistles. We all understand that. But the core idea, if you can represent this in 100 lines of code, this is something that will embody your process much better than a paper alone could be. Thank you.
Okay. So, really congratulations for a well-deserving award, and I today learned a lot of things. Thank you very much. So my question would be just a little bit, you said we have a little light on the corner and then whole wall is the dark. And you are suggesting us to look for problems and then solve it, right? So what I learned from the famous quote is that, okay, do only the things you do. So from your thing, I mean, looks like you also said you have explored a dozen of different topics, right? But what could be the 2 sentences your research area then? Like, I mean, you are focusing on one area, or you think that you are actually explored different areas of all those dozens of topics?
For me, it's not so much to go out into the dark to explore new topics, or new tools and methods of research, but it's more to find new challenges out there. There's plenty of challenges out there, and we are sometimes we focus our research too much in our little comfort zone where we actually can do research, and where we have a hammer and everything looks like a nail, and we keep on hammering that nail and everything is just fine and under control. But I think that I think it is so eye-opening to go out in the dark, as well, this is a bad metaphor, I guess, but when you go out into the dark and find, hey, there's a grand challenge out there which is insufficiently addressed, like debugging, for instance, still, and for which we really, really can still come up with good solutions to practical problems every day. And this is in contrast to come up with the umpteenth improvement to whatever corner of your specific technique, which you always can come up with an improvement, but where you always talk to yourselves. Whereas when you go out there, do something new on a real challenge, this is, at least for me, this was always so much more comforting and giving so much more meaning and so much more meaning to my existence as a researcher. So I'm happy to share.
Thank you very much.
Okay, so last question, I'm afraid, in this session.
Yeah. First, thank you. I'm a little speechless, so it's hard for me to phrase my question. But could you clue us as to how you are able to produce such magical presentations and convey a story in such an intimate way, which will forever stay in our minds?
Oh, there is I don't have too often the opportunity to get such an award and to speak such an audience, so I took some extra effort for that. Technically speaking, this is Keynote, this is PowerPoint, so there's nothing magic about this, same tool as everybody has. Technically more speaking, I came up with some fun doing some, I integrated 2 videos in there just for the fun of it, to do some animations, but that's about it. And other than that, you think about what you want to say, and you develop your stories, and then you have multiple ways to support your stories. What I teach my students that they should go and avoid is reading from their slides. So typically, I want them to come up with diagrams and have the slides and their talk interact with each other. For this talk, I wanted to come up with something special that would not be reading from my slides, but this would be slides that read from me. And yeah, it's fun, but this is actually not a style I invented myself. There's the great Lawrence Lessig, who has come up with similar talks. It takes a bit of effort because you have to memorize a lot, but you can always. But this is what anybody can do. Actually, it's only a matter of rehearsal and then presenting things.
So let's thank Andreas once again for a fantastic talk. So I'm now going to ask the General Chair of ICSE 2018 to come up to the stage to chair the closing session, and then he'll hand over to Sebastian Elbaum.
What can I say after this fantastic talk? Okay, so it's about closing. And I remember my first ICSE conference was 99 in Los Angeles. I just stopped to work at industry and moved to academia. And then my PhD student said to me, oh, there is one conference, there is one workshop, nice workshop, component-based software engineering. Maybe we can write something and maybe we can go there. And we did it. So it was the first experience, and it was kind of magic. I was so fascinated by people, by everything, by the program. That was amazing. And that fascination, I keep that all these 19 years since then. I was on every year on ICSE conference, and every time I was equally excited. At that time, I even didn't dream that one day I would organize that conference. That's the top of the top. And so it's really so great to be able to organize such a conference. But it's actually all people which do that conference. It's not me. We have been 53 organizing, 53 people working so hard during 3 years, starting 3 years ago, and accumulating this year, and then absolutely mostly work now this week. And the most I have worked with were Marsha and Mark. Please, Marsha and Mark, come here. They have worked so hard, and I learned from them so much. It was really fascinating how much details in detail they analyzed which people should be invited to program committee. So they did like Excel sheet. It was like 50 or maybe how many? 180 criteria with 2,000 people, you know, and make the matrix what would be the best fit for the program chairs, for the program committee. But that was just one detail. So thank you very much for this amazing, amazing work and what I have learned from you. Then the other thing what I would like to mention is the result of the conference or the program what was special this year. And definitely this was 50 years of software engineering and 40 edition of ICSE. And thanks to Neno and David, this was possible. So Neno and David, are you here? Yeah, they're there. So this was really data mining, and they called so many people and asked for organizers and organized writing books, and so it was really. I think that not many people can do such work. So thank you once again. Then, of course, you know, this is about the program, but the conference is not only program. It's not only about presentation of papers. It's a lot about how will you organize, how people will come to the venue, how you will make the schedule, what people will eat, how you will decorate this, how much this will cost. How will you publish that? There are so many questions, and we had so many discussions and in the local organization. So Michelle, come here, please. And Michelle is a great researcher. He's questioning everything. So we really had so much discussions about what is good, what is not good. And then we have Malin Ulfarsson. Oh, Malin is preparing for the last part of the conference. So Malin did so amazing work. So everything what you have seen, it works. It is because of Malin, because she fixed everything. Everything was a problem, Malin fixed. So it was amazing work. And then we have Jorge. Jorge, are you here? Please come. Jorge is a project manager. So everything I know, Jorge knows. So it's really not easy to organize such a big conference, you know, and especially define the budget and all details, when the buses will come, how many buses will be. Where will be the dinner, how many people will come, how these badges looks like. So thank you very much, Jorge. And then, you know, when you come to the conference, it must work. You know, that's very, very important. So even if something goes wrong, it must work. And how you will make this work? Okay, you find people who will make that work. And who is that? So I had in mind people which, you know, which are extremely systematic, which don't forget anything, which can plan perfectly, and which also can realize that. And that's Birgit and Christian. Please come here. And maybe you have seen, if there was any problem, you could ask student volunteers, and it always worked. I didn't hear any one single problem with student volunteers. They worked so hard, all the time. So please come here. So student volunteers, come here, please. Come here. So we had, Christian, how many student volunteers we had? 56? 52, yeah. So you see, it's the team, dream team. Yeah. And by this, I want to thank my family. I want to thank my wife, Gordana, first of all, because she understood this work during 3 years and extremely a lot of work during the last 3 months, not to say the last 3 weeks. And also you can see this is our granddaughter, and we start with education, so she has this Chalmers University of Technology, so I get good feeling. So thank you very much. So now I decided to do some serious business after 2 years. So that will be my next period. So I will watch some football matches. The only things I don't know is Swedish or is Croatia my team. So by that, Sebastian, please come close the ICSE 2018.
Now, not everything is scripted, and I'm going to probably maybe eat a little bit of Sebastian's bread, but we have been tremendously privileged to be able to organize this conference with Ivica, whose endless energy, whose vision, and whose determination to make it the best ICSE ever led to what we were able to observe this week. I have a feeling he deserves a standing ovation.
Ivica is begging for us to close the conference. So he doesn't know that it's not over yet, or doesn't remember. But well, let's really thank the team, Ivica. There has been an unbelievable records in numbers from the steering committee. Just a strong technical program, amazing for a year, 50-year event. The keynotes yesterday for me were like, superheroes seen here at ICSE. Just social events. We're very, very, very thankful, Ivica. Thank you very much. Thank you, team. And we close 18. This is very subtle. I'm not. Thank you very much. So a very high bar, but it's just like we had 2 people giving beautiful talks today, but as they show, there are multiple ways to succeed: PDFs, tools, PDFs. They're going to have a match right after the discussion here to see who wins. There are different ways to succeed, and just like this ICSE has been extremely successful, extremely good, fun for all of us, we have yet a couple of more ICSE plans. Actually, we have 4 in the pipeline, but we'll see 2 today. And hopefully you'll get very excited. So we're going to start with ICSE 2020. Greg Rothermel is the general chair, and he's going to tell us a little more about it. You have that one? I hope so. Yeah.
told that after today I can't come to ICSE without a sport coat. So that's ICSE 2020. I've been trying to get ICSE to happen in the place it's going to happen in 2020 for about 8 years now, and finally the time has come. We're going to be in Seoul, South Korea. First time ICSE's been in South Korea, and it's going to be May 23 through May 29 of 2020. This is a view of the city of Seoul, taken from the east. Seoul has 10 million inhabitants if you count just the ones who are in the official city center, and 25 million if you count the metropolitan areas. That's about half the population of Korea. So it's a popular place. And pay attention, if you will, to the mountain that's in the center with the thing on it that happens to be a tower, an observation tower, because I'll come back to that in a couple of slides. This is the venue. It's a new hotel, 2 years old. It's called Dragon City because it's in an area of the city where there is some history related to dragons. It's actually 3 different hotels, 3 towers, such as here, made up of 3 different hotel chains. But the nice thing is there's enough, as here, there's enough space for everything to happen. There's also enough rooms in that hotel, and they should be relatively low priced. Dragon City is located here on the map of Seoul. That tower I pointed to is, well, I don't have my pointer, but you'll see a green thing just to the right and up from the Dragon City pointer that says Seoul, and that is that mountain with the observation tower on it right there. So it's just southwest of the mountain, which is essentially at the center of things. Just north of that is the City Hall and a lot of the other interesting places. But you're really right at the center of things here. That's the Seoul subway, and so you can get anywhere that you want right from a few feet outside of the venue we're in. Nearby attractions, quite a few. There's palaces, original villages. This is the tower on top of that mountain that I showed you, and there's a great view of Seoul from there. That's a view of the city center from that tower. There's Korean food. It goes way beyond food trucks and way beyond barbecue. Myeongdong, a great shopping area. Namdaemun Market, another great shopping area. Lots of cultural events, and this is just a beginning. I'm actually a general co-chair with Doohan Bae, who was here at the start of the conference but had to leave. We've got 2 program co-chairs, Darko Mironov and Jane Cleland Huang. And we have a website up. There's not a lot there yet, but there's the organizing team and the beginnings of things, and best way to find it for the moment is to go to icseconferences.org, and you'll see it's linked from there. So that's it. Hope to see you in a couple of years.
Was that loud?
I hope that's it. All right, I'm going to be streaming these, so I need you to be off the Wi-Fi. Anytime. Trying to connect. And in the meantime, Ivica, you're a very hard act to follow. So first, I'd like to invite my OC to come on down. I am not putting on the conference. We are putting on the conference, so it's a big endeavor. And while they come down, I'm just going to give you a few fun facts about Canada. So Canada is the second largest country in the world, but it's the 38th most populous. So like Sweden, there's a lot of land and wild land. And if you spend some time in Canada after the conference or before the conference, there's lots of things to do there. This is home of Santa Claus. So Santa Claus has a place where you can write to him with the postal code H0H0H0, so send your letters there. Canadians are very proud of their country, of their citizens. We just tend to be fairly reserved about it. It's actually fairly rare. And so we tend to just kind of slip it into conversation without you even knowing it. So, like, David Parnas, it's too bad he wasn't here for the anniversary. He's Canadian, So let's just get it out of the way. There are a number of companies that hopefully you know about, but you might not know they're Canadian. So CAE has most of the world market in flight simulators. IMAX, the technology of IMAX was developed in Canada, And Seagram's, well, you have to be of a particular vintage to know what Seagram's is. So we're going to be in Quebec. Quebec's the largest province in Canada. Quebec is over 400 years old. I know that's not very old by European and Asian standards, but it's ancient by North America standards. Montreal is not the provincial capital. Quebec City is, but Montreal is the largest city in Quebec. French is the official language, so if you speak French, excellent, come. But be reassured that the vast majority of the population is bilingual English and French. It's the show you where Montreal is. So Montreal is actually a river. It's a city on an island in a river. It's really nice today there, 22 degrees. And it's got extensive collection of public art. So written into the provincial policy is a rule that any public institution that's built almost 1% of the funds that go into development go into public art installation of some sort. So it is a fabulously artful city. We're going to be at the Fairmont, the Queen Elizabeth. It's a historic hotel. It's an iconic hotel. It's where John Lennon and Yoko Ono had their sleep-in. And it's on top of the train station. They closed for an entire year to be completely renovated. So even though it's a historical hotel, it is completely renovated as a business center. So it's a fabulous location for ICSE. We will be occupying all of it, and there'll be lots of space for informal meetings as well as formal meetings. So ICSE program looks a lot like what you're used to. So many of the same tracks. We are in line to have most of the same co-located events. We have some differences that we would like to tell you about. So I'm going to have various track chairs come up and say a few words, starting with John and Tefik.
We just wanted to make 3 points. One is double-blind submissions. We'll continue with double-blind. For double-blind to work, authors have to anonymize their submissions, and they have to be very careful with the conflict of interest. When you mark your conflict of interest, you have to be very thorough, so we count on you. Please pay attention to that. There is one change we are doing for next year, no supplementary files with the paper submission. We just want the PDF for the paper, but there is going to be artifact. I think that's going to be mentioned, so you can, accepted papers will be able to submit the artifacts to the artifact track.
And one thing that won't change, of course, is that you should submit your best work to ICSE 2019. Now, I have a recommendation for how you should do this. So many of you will be taking flights from here to go home. some of them long, some of them short. If you're going to Australia like me, it's going to be pretty long. That's a great time to start writing your ICSE 2019 papers. So get started on those now, and let's get lots of great papers for next year. Thank you.
So Mike?
Well, save some of those great papers for SEIP. We're really just trying to continue the great work that was done this year by Jan and Francis, really trying to be inclusive and bring in industry. 400 industrial participation people at the conference is really impressive. So our goal with SEIP is to try and take this research that we have and have it ripple out to the world. And to that end, we are trying to find both excellent industrial research and reflective practitioners who can take this research and take it into organizations and really make an impact. For submissions, we're going to have our regular papers and talks, but we're also going to try and have interactive sessions, and we don't know what those will be yet. Maybe the crazier the better, but it could be goldfish bowls or maybe local industry people coming up and telling us the problems that they have. We don't know yet. If you have creative ideas, let us know. And I hope if you have industrially relevant problems, you will propose something that's new and novel. And spread the word. Thank you.
So, so we're going to try to supplement SEIP with a number of invited talks and activities into a two-day program. So we'll be bringing in some hands-on tutorials. There'll be a student industry lunch and a resume database for matching students. And maybe some attendees who are looking for internships, looking for jobs. Artifact evaluation is new, so I'm going to have Paul talk about that.
Yes, hello everybody. I'm very happy to be a co-chair for this new track. So for the first time, there will be an artifact evaluation track at ICSE. Andreas already said in his talk that a scientific result should be more than just a paper. You said there should be a tool, but I think there should be a digital artifact coming with that paper. So we will invite all the authors of accepted papers to submit their digital artifact. The artifacts will be evaluating following the ACM policy to evaluate the maturity of the artifacts. Yes, I can only say, please, when working on your paper, already think about preparing that artifact. So we will give you some time after the notification deadline, but I think it's good to prepare it in advance and to think about it in advance. So we're looking forward to receiving many artifact submissions. Thank you.
And one thing new this year will be an SE mentoring workshop, and Lloyd's going to talk about that.
Good afternoon. So I'm the CRA education co-chair, and one of the things we've observed is a lot of academics worrying about the graduate student pipeline. And so we're going to create a workshop for student mentoring workshop the day before ICSE begins on Tuesday. And the idea is to bring undergraduates and first, second, third year graduate students who might have not thought about graduate school to come to ICSE, come to a mentoring workshop the day before. And so our call out to you is if you have undergrad researchers, have them apply, or if you have a special place where you might think may give us funding to help with their travel funds, you can also contact me. So the goal is to increase that pipeline by getting these students to an actual research conference so they can see what all the cool things are that we do here.
All right, so we're aiming to put together a stellar program. We are also going to be in a stellar city after hours. There's the city to enjoy. So that's it. See you next year in Montreal.